Hi there, it's Brian Su again, and today I'll be doing a short review of the Uniross high-speed charger turbocharge. But before we go into the details of this, you might remember that a few weeks ago I did a short review on the Nightcore DC Charger D2. So once again, just to recap, this is a one-for-all charger. It's got an LCD display that shows you the charging mode, the remaining charge capacity that needs to fill the battery up. It is a one-for-all charger. It handles a wide variety of chemistries like lithium ion, LiFePO4, nickel metal hydride, and NiCad. It's triple voltage, so it takes 12 volts and it takes 110 and 220 volt AC via this connector. So while this was a one-for-all charger that's meant to replace every other charger that you have, which is what makes this a good investment. It's a real space saver and it's convenient to have. But while that's a universal charger, this here is something at the other end of the spectrum. This is the Uniross high-speed charger. In fact, this is so specialized that it only charges nickel metal hydride cells. It does not handle NiCad battery chemistry, and I'll explain why that is the case in a short while. So let's go ahead and unbox this. It comes in a clamshell that's ultrasonic welded, but of course I've cut the edges off already. Okay, so this is the charger unit itself, and if you're not familiar with high-speed chargers, by the way, this one charges the batteries in just 15 minutes or thereabouts. Okay, the way high-speed chargers work is they push a very high amount of current through the cells and thereby generating a lot of heat. Okay, so before we go into that, just want to point out a few things here. These chargers, because of the high current it uses to charge the batteries, they require a very high input current as well. So if we look at the back here, and by the way, there is a cooling fan there, which we'll see a demo of shortly. So if we look at the input here, it says 11 to 16 volts DC at 4 amps, and that is a very high current rating for a battery charger. So these chargers charge nickel metal hydride batteries by pushing a whole load of current through them and trying to get them charged up in 15 minutes. If you watched my review of the Nightcore, I did mention how these chargers use a method called DV-DT to charge nickel cells. In this case, it's the same thing. So one of the characteristics of nickel metal hydride batteries and NiCad batteries is that as they get fully charged, the cell voltage actually drops. And yes, that's right. So as the battery is being charged, the cell voltage increases and it gets to a point where the cell is fully charged and then the voltage starts to fall. The digital chargers like this will detect that fall in, or rather the drop in voltage, and determine the cell to be fully charged. When it comes to fast chargers like this, it also takes advantage of another characteristic of nickel chemistry cells, which is the fact that their temperature rises sharply once they are fully charged as well. So This unit here actually monitors the voltage and the temperature of the cells very carefully, and it needs to do that because if you think about it, charging a battery in 15 minutes will require pushing a lot of current through them, and some of the cells could already be 50% charged, and some of them could already be 80% charged, and if you charge those for 15 minutes, they're going to get really hot, and it will burn the cells, and their life will be shortened. So let's go ahead and look at what else is in the clamshell. Most of these, in fact all the 15-minute chargers that I've seen do come with a 12-volt cord, which is ideal because of the high current supply from 12 volts. Okay, it comes with a dual voltage AC adapter as well with a cord. Now this adapter is a switching mode power supply, as it clearly says there. Its output is a very high 4 amps at 16 volts. Now the thing about this type of chargers is that they always come with a very high current output AC power adapter to supply the required current to the actual charging unit. In the past, 15-minute chargers like this used to come with non-switching mode power supplies, and those type of power supplies are really heavy because of the large transformer block in them that is required for the high current output. The way switching mode power supplies work is that the circuitry oscillates the AC voltage going into the transformer at a very high frequency, so they could be going as high as a couple of thousand hertz or rather kilohertz instead of the standard 55 hertz from the AC power supply. When you do that, you can get a much higher current output from a smaller size transformer, which is why this unit here isn't actually too heavy. But I can assure you, if you dig up an old power supply adapter from a gaming console or something about 10 years ago, you'll find that those only output maybe 1 amp or maybe 2 amps, and they will weigh a lot. You can literally feel the weight of the transformer. This one here isn't too heavy at all. I once had a Uniross Express 300 charger which looks just like this. Now that charger was a dumb charger, and what I mean by that is there is no mechanism to detect whether a battery is fully charged or not. It just simply supplies the battery with a constant current for 8 hours and then it cuts off. They call it an express charger because the normal chargers would take about 18 hours to charge a battery or so. So 8 hours was quite quick by comparison. I just wanted to say that the Express 300 that you just saw weighs more than this power supply alone, because the transformer block in that unit was quite heavy because it was a non-switching power supply. So just wanted to illustrate the weight savings that you could achieve from a switching mode power supply. In the past, there were 15-minute chargers made by GP. Now theirs came with a non-switching mode power supply, and the unit was really heavy and impractical. This one here is it's quite a good weight. Okay, so let's move on to demonstrate how this charger works.